Well, good morning, geometry students. It's Thursday, January 13th. Um, I'm sure you can hear I am still sick. My voice is getting better, but I'm still congested. My sore throat's mostly gone, but now I have a cough. I am hopeful that by Tuesday I'll be symptom free and back in the classroom with you. I'm very much looking forward to getting back to work. Um, but I hope that you're healthy, wealthy, and wise. As always, let's go through some of today's work. So I just created a bunch of angle puzzles like this one from yesterday's assignment for you to work on, and then solving equations. And I just made some challenging ones. And so we'll talk about both in this video. First, I'm just going to go through the solutions to this angle puzzle from yesterday, just to sort of remind you how all this works. And hopefully it'll help you to see if you got it right or not. So, of course, um, I'll just go through it one by one. Let's start with, and I'll go through alphabetically. For A, I have what is that, a hexagon? And it's a regular hexagon because all of these angles are marked as congruent. And so using the polygon sum theorem, I know that, again, it's 180 times n minus 2, well, that n is 6 in this case, divided by n, will calculate the value of A, and it's 120 degrees. And so if I know that's 120, then this is also 120. And calculating B, just like the example we did yesterday, it's a linear pair with that 120, so B is 60 degrees. Well, this is also 60 degrees because of the same reason down here. So that means that using the triangle sum theorem, I can calculate that C is also 60 degrees. In other words, this triangle that we see here is an equilateral triangle. It's also equiangular, but it's a regular triangle. So we got those done. Now let's find D. Remember, it's given that L is parallel to K, and that's significant because using the vertical angles theorem, I can figure out that this angle is 60, and then the same side interior angles would prove that D is 120. There's another way, right? This is 120 because of linear pair property, and D is an alternate interior angle with that 120 degree angle. Anyway, D is 120. To find E, note that, hopefully you notice this, this is a vertical angle with angle D, but it is bisected by this segment here. And so E is half of 120, or it's again, your good friend, 60 degrees. So E is 60, as is this angle here. This is a linear pair, and it's given that it's a right angle. And so we obviously know that that's a 90-degree angle. So by the triangle sum theorem, F would be 30 degrees. Making our way to G here. Well, that's a regular pentagon. And so again, doing 180 times n minus 2 divided by n, we know that the angles in a regular pentagon are 108 degrees. So G was 108. This is also 108. Now, finding M is maybe the most involved of any of these problems. So in order to do that, I'm actually going to zoom in on this a little bit. Let's see if I can do that so I can write a little bit more clearly. Now, did you notice that this is a 72-degree angle right here? Because it makes a linear pair with that 108-degree angle. This is a 60-degree angle by so many different reasons, right? It's corresponding or linear pairs or whatever. And so using the triangle sum theorem, I can calculate that this angle up here has to be, I believe it's 48 degrees, this one right here. Let me just check that. 60 and 72 is 132 from 180 is, 48 degrees. So that's 48, and this is 108. That makes a linear set with M. And so I'll add 108 to that 48, and I get 156 degrees. And so in order to calculate M, I'll use the linear set property and just subtract from 180. And it looks like it's 24 degrees. So M is a 24-degree angle. Zoom back out, and I'll write it up here. And then P, finally, to find P, well, notice that it's a vertical angle with this one here. And this is a 72-degree angle because it's a linear pair with this 108. 72 and 24 is 96. And so by the triangle sum theorem, P, which is a vertical angle with that triangle, or with that angle from the triangle, would have to be, I believe, 84. If I do 180 minus 96, I get 84 degrees. So the ones that you'll find on today's assignment are maybe a little bit more challenging than this, but it's a lot of the same properties. So continue to work hard on those. Now, solving equations like this first one that I'm going to do for you, I just wanted to remind you how the fraction stuff works. So I'm going to start by distributing this 4/3 through, and I got to do 4/3 times 2. 4/3 times 2x. Remember that you're just multiplying across. 4/3 times 2x is 8/3 x. 4/3 times 9, if I do 9 divided by 3 first, and then 4 times 3, I get 12. And then I guess I should combine these like terms. 12 minus 10 is positive 2. And then finally, we'll just solve it, and I'll subtract 2 from each side. And so I have 8/3 x equals 72. Now, you probably remember how to get rid of this fraction, but let me just remind you, you multiply by the reciprocal. The reciprocal of 8/3 is 3/8. When I multiply 8/3 times 3/8, one way to think of it is I get 8, 8 times 3 is 24, 3 times 8 is also 24, and that's 1. So if I multiply this by 3/8, I'm not going to get 1, I'm going to get 1x, which is where I want to be. And I can also cross-cancel these 8s and cross-cancel these 3s. But whatever I do to one side, I do to the other, so I'll multiply this by 3/8. Now 72 divided by 8 is 9, and 9 times 3 is 27. Oh my gosh, I wrote a 4 when I meant a 7. It's 27. Okay, and you could go back and check it, but I'm trying to make this a short video today, so let's just move on. That's how fractions work. Now, the last thing that I wanted to talk about is this problem here from the assignment that I gave you today. Is very challenging. So I'm not going to do the whole thing. And in fact, if you are a student who enjoys challenge, stop the video now. Don't just try to solve this on your own. But I'm going to give you a hint on an easy way, or not easy, but a better way to solve this. But I think the first thing that I'm going to do is I'm going to distribute this 5 halves, and I'm going to distribute this 5 quarters, just to get rid of the parentheses. It might make this a little bit easier to understand. It might not. I don't know. 5 halves times 7x is 35 halves x. 5 halves times 3 is negative 15 halves. Let's see. 5 quarters times 9 is 45 quarters. And 5 quarters times 9x is 45 quarters x. And then you start looking at this and you go, there's a lot of different fractions with a bunch of different denominators. This is going to be challenging. I'm going to have to find all these common denominators. But just ask yourself in your head for a moment, what is the common denominator between 2, 3, and 4? It's the least common multiple. And the answer is that it's 12, okay? The least common multiple is 12. 2 times 6, 3 times 4, 4 times 3. And what that means is if I multiply this entire equation by 12, every single part of this equation by 12, I'm going to eliminate every single fraction, every single denominator. Now, I'm not going to do this. It's up to you. You would multiply each and every term by 12. And the halves will go away, the thirds will go away, and the quarters will go away. But you can't forget to multiply this 1 by 12. I actually did that yesterday when I was coming up with the answers to this. And I was confused because it didn't work. You got to multiply every single thing by 12. I'll do the first one. 12 times 35 halves. If 12 divided by 2 is 6, so it's going to be 6 times 35 x, right? I'm just cross-canceling the 12 with the 2, and I can cross-cancel with the 3 and with the 4, and you can find each of those values. And then even though you're going to have bigger numbers here, with a calculator, it's not that difficult to combine like terms and so on. So that's your hint. Good luck today. I hope that you're doing well and that you're remaining healthy. I really do. I can't wait to see you again on Tuesday. So take care of yourselves, and I'll see you tomorrow for our last YouTube lesson.